Hey everyone. So today what we're going to be doing is we're going to be proving different shapes are squares, rhombuses, rectangles, parallelograms. The only difference compared to what we've been doing the past few days is that we're going to be using the coordinate plane to do it. So to start, we're going to review parallel and perpendicular slopes. So if we're looking at this first box, it tells us that parallel slopes are going to be equivalent. So when we're comparing two slopes, if they're the same number, that's going to tell us they're parallel. If we want perpendicular slopes, we're going to be having our numbers be opposite reciprocals of each other. So looking at this table, we're just going to look at some examples. If we start with an original slope of 3, if I want to write something with a parallel slope, I just need to make it the same number. So we bring down the 3. If I am trying to do a perpendicular slope, I write the opposite reciprocal. Just as a reminder, opposite refers to the sign. So if I started with a positive sign for positive 3, my perpendicular slope will be negative. And then we're doing reciprocal. So it's where we flip-flop numerator and denominator. But when we have a whole number, it's like 3 over 1. So we're flip-flopping 3 and the 1. So the perpendicular slope to 3 is negative 1/3. Let's look at negative 2/5. If I want to write a parallel slope, it's just going to be the same number, negative 2/5. If I want a perpendicular slope, doing opposite reciprocal. I see that the original slope had a negative sign, so my opposite sign would be positive. And then reciprocal, I just flip-flop numerator and denominator. So perpendicular slope to negative 2/5 is 5/2. And then let's look at something with the original slope of 0. If I wanted a parallel line, it would still be 0. And then if I wanted the perpendicular slope, this is kind of the wacky one. Um, this is just kind of something you would want to memorize, is that the perpendicular slope to 0 is undefined. And remember, undefined is just a vertical line, which makes sense because something with the slope of 0 is a horizontal line. So it makes sense that those are the two perpendicular slopes. But now we're going to practice just writing in slopes that are parallel and perpendicular. So if we start with 12/5 as our original slope, we want a parallel slope. We just write the same number again, 12/5, perpendicular, opposite reciprocal. So I want the opposite sign, which is negative, and then I'm going to take the reciprocal, flip-flop numerator, denominator. It's us 5 over 12. So negative 5/12 is the perpendicular slope to 12 over 5. Let's do parallel. Okay. So I have negative 14. Parallel slope will just be negative 14. If I go perpendicular, take the opposite sign, so positive for my perpendicular slope, and then the reciprocal. Remember, whole numbers are like they're just over 1, so we're flip-flopping the 1 and 14. So that perpendicular slope to negative 14 would be 1/14. Right, let's do negative 1/4. If we want a parallel slope, we just keep the same number. Perpendicular, opposite reciprocal, that's just going to be positive 4. Yeah, if I want a parallel slope to undefined, it's just going to stay undefined. If I want the perpendicular slope, kind of the same idea we did on that left table. We know that the perpendicular slope to 0 is undefined. It works backwards as well. So the perpendicular slope of undefined is 0. Last one, we're going to have a parallel slope to 1/3, just 1/3. And then perpendicular slope, we do opposite reciprocals, which is just negative 3. So that is like a crash course review over parallel perpendicular. Now we're just gonna, re-go over how to find slopes when we're given a graph. Right? We define slope as rise over run. And so for this unit, what we're gonna be doing is we're just gonna be physically counting our rise and our run. So I start with my rise. So to rise, I'm gonna go from B to A. So I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I get a rise of 10. Okay, now I'm going to count my run. I go, and I'm going left to A. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going left 10. Right. So now I've done the count, I want to now put it into that fractional rise over run. So I rose 10, and when I ran left 10. Always as a good reminder, when we run left with slope, that's going to be negative. So we have a negative 10. If it had been to the right, that's where we get a positive 10 on our run. right? At this point, this can simplify further. We're always going to want to simplify our slopes to the simplest it can be. This will actually simplify down to -1. So our slope is -1. And then it wants us to write the perpendicular slope. So we're going opposite reciprocal. That's going to get us +1, right? Opposite sign is positive. And then reciprocal of 1 is just 1. Okay, so that is how we find slope. Let's go ahead and move down to this flow chart. Yeah. So this is going to help us when we start actually using the graphs, because what we're going to do is we start with looking at the number of parallel sides, so either 0, 1, or 2. If it has 0 or 1 pairs of opposite parallel sides, that's actually just going to be like the other quadrilateral. We're not going to go too super hard into kites or trapezoids for this. And then if it has 2 pairs of parallel sides, right, we are going to be using this bottom row. So you can ignore that middle branch about diagonals. So we're going to the bottom row if there's 2 pairs, right? And then we'll be looking at the distinct differences between rhombuses, rectangles, squares, parallelograms, to give us the most precise name. So let's go ahead and just do an example. So we have this figure A, B, C, D. We want to find the most precise name for the shape. So anytime we have one of these questions, you need to find the slope of the line and you need to find the length of the line. Let's start by finding the slope. We go AB, I go rise over run, just as a reminder. Gonna put it on the top here. We go rise, 1, 2, 3, and then I run 1, 2, and I run to the right, so that's a +2. So in a slope form, it's just 3/2. Okay, let's try BC. BC, right, I start with my rise, so that's 1, a rise of 1, and then I run 1, 2, 3, 4 to the right. Okay, so when I write that as a slope, that is 1/4. Okay, now we're going line or segment CD. Remember, I always start with the rise, so I rise 1, 2, 3, and then I'm going to run to C, 1, 2. So I actually ran 2. So as a slope, that is 3/2. All right, and we do this last one, AD. So we start with rise, we rise to A, or we rise from A to D. That's just a 1, and then we run 1, 2, 3, 4. That was a slope that would be 1/4. All right, now we need to find the length of each line or each segment. So let's look at AB first. When I was counting out my slope, right, I drew in like a triangle. The nice thing is that this triangle is a right triangle. Okay, so now I'm looking at a right triangle with sides 2, 3, and AB, where AB is our hypotenuse. Since I have a right triangle, I can use the Pythagorean theorem to solve for AB. So I'm going AB squared is equal to 2 squared plus 3 squared. So let's simplify that right-hand side to get us 13, and then we square root on both sides. And then for this unit, our square roots, we're going to actually round them off to the tens place. So square root of 13 is equal to 3.60. So that just stays 3.6. All right, let's go ahead and try BC now. Again, anytime we're doing our counting and we're drawing that in, we're forming a right triangle with the 2 counting numbers and then the side length we were trying to find the slope of. So we have a right triangle with side CB 1 and 4. So we know CB squared is equal to 1 squared plus 4 squared. We simplify that right-hand side to get CB squared is equal to 17. And right now we're just solving for CB. So CB is going to be equal to the square root of 17. And let's go ahead and get that in decimal form and rounded. So that's 4.12 rounds to 4.1. Now let's go ahead and look at CD. So CD, you have that right triangle right here. Okay, so we know CD squared is equal to 3 squared plus 2 squared. Okay, so now we just simplify and solve. But wait a second. I see that I have already solved for a missing side links whose different, like the different counting steps, right? Or 2 squared and plus 3 squared, or 3 squared plus 2 squared, right? Because of the commutative property. But I actually know that CD squared, or CD, when I simplify all the way through, is just going to be equal to 3.6 because I already solved for it when I solved for AB. However, if it's helpful, go ahead and just work through it real quick. Make sure that it double checks. Right. Now we're going to do side AD. Right, here's our right triangle that we're going to use for Pythagorean theorem. We have AD squared is equal to 1 squared plus 4 squared. Again, I have already done this 1 squared plus 4 squared simplification of a side, right, when I was working through the length of CB. So I know already that this is going to simplify down to 4.1. But again, go ahead and check it for yourself if you need to. Okay, so I've now found all the slopes, all the lengths of both sides. I'm going to go back to this chart. So we're going to start with how many pairs of opposite sides are parallel, 0, 1, or 2. So, right, we're looking for slopes that have the same number for this part. So in my slope column, I see 3 halves and 3 halves. That refers to my AB and my CD. Right, so we know that those two lines are parallel to one another because they have the same slope. So let's go ahead and draw that in. Right, and I see that they actually do fall on opposite sides. So I have one pair of opposite sides so far. All right, let's see if there are any more. I see 1/4 and 1/4. Refers to my BC and my AD side. Let's go ahead and draw that in and make sure that if they're opposite, and they are in fact opposite. So I have 2 pairs of opposite parallel sides. So if I have 2 pairs of opposite parallel sides, all right, I'm going all the way over to this last branch, and I'm jumping down to its bottom row. So I'm trying to decipher if I have a parallelogram, rhombus, rectangle, or square. I think the next easiest step is just to see if you have all 4 congruent sides, because if you do, that's going to clue us into we're looking at a rhombus or a square. Right. However, we see that we do not have 4 congruent sides, right? These are 3.6, 4.1, two different numbers. So that nixes out rhombus and square for this problem. So it means it either has to be a parallelogram or a rectangle. The key difference, right, is noted here that rectangles, we want all 4 angles to be right angles. So to do this, we're actually going to look back at the different angles being formed by the intersection of those segments. And we're going to be looking at those segments slopes, because if their slopes are perpendicular to one another, that means that we are going to be forming a right angle where they intersect. So let's pick on segment AB and BC. So we're going to look at their slopes. So I see they have one has a slope of 3 halves, one has a slope of 1/4. Okay. Both of these slopes are positive, which means they wouldn't ever be opposite reciprocals, which means they will not be perpendicular to one another. So we do not have a right angle for this angle B here. Right, since we don't have right angles, all 4 angles are right angles, this is going to tell us the most precise name we can give it is a parallelogram. Okay, let's do another example. So we start by finding the slopes of all the sides. So AB, there is no rise, so we're just counting the run. 1, 2, 3, 4, 5, 6, right? So we have a positive 6 and a rise of 0. So that's going to be 0/6. That simplifies down to 0. Let's look at BC. I rise 1, 2, 3, 4, 5, 6, 7. And then I'm going to run, and I run to the left. 1, 2. Right, and since I'm going to the left, that makes it a -2. So putting that in slope form, we get 7 negative halves. That's as simplified as it's going to go. All right, let's do CD. Yep, so CD, I go 1, 2, 3, 4, 5, 6, 7, 8. But I have a rise of 0. So this is going to simplify down to 0. Sorry about that. And then I have the side AD. Okay. That's going to go no run, but we just have a rise. So we go 1, 2, 3, 4, 5, 6, 7. We have a rise of 7, but we have no run. So we have a run of 0. Anytime we have a 0 in that slope denominator, it's going to tell us the slope is undefined, which makes sense though, because we're working with a vertical line. So now we find the lengths of all the sides. Okay, so we have this first one where we have AB, right? We said that there's no rise, so only a run. So our length is just going to be whatever the run was, which was 6. And lengths always need to be positive, as a reminder. Let's go ahead and do BC. BC has a rise of 7, a run of -2, and we form that right angle. So we know BC squared is equal to 7 squared plus 2 squared. And remember, we only want to look at we care about the counting steps in when we do the Pythagorean theorem, not necessarily the sign. So 7 squared plus 2 squared. So that's going to get us BC squared is equal to 53. We square root both sides. And then we round this off to the 10th. So square root of 53 is 7.28. So we'll go 7.3. Yeah. Let's look at CD. CD doesn't also not have a rise. So we're just looking at the run length, which was 8. So that's the length of the side. And then we do AD. AD did not have a run. So we're only going to be, to find the length, we're only going to be looking at that rise measurement. And that was 7. Okay. So let's go back to the chart. First thing we're looking for is how many pairs of opposite parallel sides are there? Okay. Well, let's look for our slopes that have same numbers. Okay. I see a 0, I see a 0. So that tells me AB and CD are parallel to one another. So let's go ahead and draw that in. We have AB and DC are parallel. And then 7, -2, and undefined are not the same number. So that's the only amount of so we only have one pair of opposite parallel sides, which means we're actually going to be here in that second branch, which is just going to be like other quadrilateral. So the most precise name I can give this is like other quadrilateral. Okay, let's do this next one. So we're going to start by finding the slope of all the sides. So JK, we rise 1, 2, 3, and then we run 1, 2, 3, 4, 5, 6, 7, 8. So that has a slope of 3, -8, because we ran to the left. KL, we rise 1, 2, we have a rise of 2, and then we run to the right 1, 2, 3. In our slope form, that'll be 2, 3, not negative. 2, +3. Okay, let's do LM. So we start with a rise 1, 2, 3. So it's a rise of 3. And then we run to the left 1, 2, 3, 4, 5, 6, 7, 8. So we run to the left 8. So when we put that in the slope fraction form, we get 3 over -8 again. And then we're going to do MJ. So we rise 1, 2. We go to the right 3. Okay, now we need to go ahead and find the length of each side. Start with JK. Here's that right angle I've been talking about. So we're looking at a triangle, or a right triangle with the side lengths JK, 3, and +8. So let's go ahead and just do that right here. JK squared is going to be equal to 8 squared plus 3 squared. Go ahead and simplify that right-hand side. So JK squared is equal to 73. We solve for JK. The square root of 73 when we round is 8.54, so we round off to just to that 5. 8.5. Okay, let's look at KL. Right here's that right angle. So we can use Pythagorean theorem. KL squared is equal to 2 squared plus 3 squared. So when we simplify that right-hand side, we get 13. Where root both sides. So we get KL, and then the square root of 13, when we round off, is 3.6. Okay, go ahead and do ML. We know that we form this right triangle here. There's our right angle. So we go ML squared is equal to 8 squared plus 3 squared. Right, again, I already found, like, I've already computed what 8 squared plus 3 squared is equal to, right? When we solved for JK. So I already know, I've already done it. ML is also going to be equal to 8.5. If you need to simplify it all the way through, though, I recommend that you go ahead and do that. And then we're going to finish with MJ. MJ squared, right? Because we have that right triangle, is equal to 2 squared plus 3 squared. And again, I already found how 2 squared plus 3 squared simplifies when I was solving for KL. So I know that MJ is also going to be the same number, so 3.6. Okay, let's go ahead and look at our tree. Right, first thing we want is figure out how many pairs of parallel lines do we have. So we're looking at what slopes are the same. So I see a -3/8, a -3/8, referring to KL and LM. Go ahead and mark them parallel. So we have JK is parallel to LM. All right, so we have one pair of opposite parallel sides. I also see another pair of the same number, so 2/3, 2/3, referring to KL and MJ. Go ahead and mark those as parallel. And I see that they are in fact opposite from one another. So I have two pairs of parallel sides. Okay, so I'm jumping all the way down to this last branch. So now I got to figure out if it's parallelogram, rhombus, rectangle, or square. So first I'm going to start by looking at our side lengths, right? We don't have four congruent side lengths. So if we don't have four congruent side lengths, that already nixes out rhombus and square. So similar to what we did the first time, we're comparing if there are right angles or not. So we got to do that. Let's just look at where JK and LK intersect to get us K, and we need to see if that's going to be a right angle or no. And we're going to do that by seeing if those slopes are perpendicular. Okay. So if I'm just going to write what the perpendicular slope to -3/8 should be, the perpendicular slope to -3/8 should be +8/3, right? And that is not what KL is equal to. So that tells us that we do not have perpendicular slopes, therefore we don't have a right angle where these lines intersect. So since we don't have a right angle, the most precise name I can give this shape is a parallelogram. Okay, let's go ahead and go through this last problem. So start by finding the slope of each side. We have CB, 1, 2, the rise to the run, which is 1, 2, 3, 4. So we have 2/4, which reduces down to 1/2. Now let's do BE. We rise 1, 2, 3, 4. And then we go left 1, 2. So in slope form, that's going to be a -4/-2, which reduces to -2. Let's go DE. So we start by rising 1, 2, and then we run 1, 2, 3, 4. In slope form, that's 2/4. We simplify to 1/2. And right, let's finish off with CD. We start by rising 1, 2, 3, 4. So we have a rise of 4, and then we run left 2. So we get 4/-2. Okay. Now let's find the lengths of all the sides. We'll start with CB. We know, right, that we have this right angle here for CB. So we get CB squared is equal to 2 squared plus 4 squared. We go ahead and solve all the way through. So 2 squared plus 4 squared is going to be 20. We root both sides. So CB is going to be equal to 4.5. All right, let's go ahead and do BE. We have a right triangle with the side BE, 2 and 4. So we know BE squared is equal to 2 squared plus 4 squared. All right, hold up. I already calculated 2 squared plus 4 squared and simplified, right? I did that for CB, so I know that BE is going to be equal to 4.5. Okay, let's do DE. Yep, DE. So we know DE squared is forming that, we have that right triangle, so we know DE squared is equal to 2 squared plus 4 squared again, which I already calculated, right? It's 4.5. Again, though, if you want to go through and you want to double check, by all means, go ahead and do that. Let's do CD. Right, here's our right triangle that we formed. So we know CD squared is equal to 2 squared plus 4 squared. So when I simplify that down, I already know what that is. It's going to be 4.5. Okay, we found all the slopes, all the links. Let's go to our chart. First thing we need to figure out, how many pairs of opposite parallel sides do we have? Okay, so we're looking for slopes with the same number. Okay, I see 1/2 and 1/2, referring to CB and DE. Okay, let's go ahead and mark those parallel. So we have CB and we have DE. Okay, we have one pair of parallel sides. I also see another pair of same numbers, that -2. Oops, I did not simplify that down. There we go. So I have another pair of same numbers, -2, -2, referring to BECD. Okay, go ahead and mark that. So I see that I have two pairs of opposite parallel sides. Okay, I'm jumping down to this last branch. We go down to the bottom line, all right? Parallelogram, rhombus, rectangle, square. All right, so we're looking, let's start with just looking if we have four congruent sides. We do. We have four congruent sides, which means we're working with a rhombus or square, right? What's that key difference between rhombuses and squares? Squares are going to have those four congruent right angles. But now I got to see if all of these angles are right. So to do that, let's pick on two different slopes that are right next to each other. So let's look at CB and BE. Let's look at their slopes. All right, we want to see if they're opposite reciprocals, right? Because that's going to tell us if they're perpendicular. So 1/2's opposite reciprocal is going to be -2. Okay, it matches. So where those two lines intersect are going to be perpendicular. They're going to be right angles. Okay, let's look at BE and DE. We have -2, 1/2. Look at that. We have opposite reciprocals again. Since they're opposite reciprocals, they're perpendicular. Therefore, where they intersect are right angles. Okay, if I look at DE and CD, I see again that I have opposite reciprocals. So where those two lines intersect is going to be a right angle. And then looking between CB and CD, I have -2 and 1/2. Right, opposite reciprocals, therefore they are perpendicular to one another. So I have four right angles, which means I am working with a square. That's the most precise name I can give. All right. If you have any questions, feel free to reach out or come to the tutorial and ask your questions. Other than that, have a great day.